Alright kids, in this question they're asking us to find I1 here, I1, I2 and the charge of this capacitor. Right, to find everything we need to find the direction of currents and everything. So let's finalize the direction of currents. Okay, so now this main current comes from here, comes there to this junction, and current gets into two different paths, this path and this path. So this is I2, it will come to this junction and it will be back. Right, again this current goes to 1 kilo ohms, 3 kilo ohms, and here the current will not go through this capacitor because DC current, it won't go through a capacitor, you know that. So the current will come there, it passes this junction and back to the cell again. Right, now we know the path of the current. Right, now we can find the total current. I1 is the total current, you can see. So let's add all the resistors, then we can find the equivalent resistance. Let's start from here. 1, 3, 6. So these three resistors are in series. So you know series resistors. So we add them together, R1, R2 and R3. Let's say, so it's 1 plus 3 plus 6. So we get 10 kilo ohms. Then we can assume we have a resistor 10 kilo ohms here. This 10 kilo ohms resistor and this 10 kilo ohms resistor, they are parallel, starting from this point and terminate at this point. So these two resistors are parallel. So you know how to add parallel resistors. We have to take 1 over R1 plus 1 over R2 equals 1 over R method. So 1 over 10 plus 1 over 10 equals 1 over R, 10 over 2 over 10, so 1 over R. So we have to take the reciprocal of it. So R becomes 10 over 2, that's 5 kilo ohms. Right. Let's get into proper diagram now. Right. Okay. Now we know instead of all these 4 resistors, we can put one resistor 5 kilo ohms. Right, this one. These 15 kilo ohms and these 5 kilo ohms are in series. Right, so just like earlier, we can add these two, 15 plus 5, that will be 20 kilo ohms. Right, now we can apply V equals IR. Right, so V 20, I, that's I1 here, into total resistance are 20 kilo ohms. So 20 divided by 20, that's 1, but still divide by kilo ohms, so 10 to the power 3. So I is 1 into 10 to the power minus 3, that means 1 milliamperes. Right. The next thing we need to find is current I2. Right. Now we know current 1 milliampere current will come to here, 1 milliampere. Then it has two similar paths. So that means it will go in equal value through these two paths. So 1 into half, so that's 1 divided by 2 milliamperes. So we can conclude 0.5 milliampere as I2 current. Right. The last thing we need to find the potential difference across this capacitor and the charge of it. So potential difference, right, to find potential difference, I know this 6 kilo ohms resistor and this capacitor, you can see these two are in, yes, parallel. So if I can find the potential difference across 6 kilo ohms, then the same potential will be shared by this capacitor. So the current through this 6 kilo ohms, you can see 0.5 milliamperes comes over here, right? 0.5 milliamperes will go through this 6 kilo ohms resistor. So the potential difference across 6 kilo ohms, I write it here. Potential difference across, let's say, 6 kilo ohms. Let's apply V equals IR. So 0.5 milliamperes 10 to the power minus 3 into 6 kilo ohms 10 to the power 3. I get 0.5 into 6, that's 3. This one and this one will cancel off. So 3 volt. Right. The diagram will be something like this. So 3 volt. And the charge of this is fine. The charge of it, the capacitance of it 2 microfarad. Right. 2 microfarad. 2 microfarad. Right. Here, what we can do is we know the potential difference. Now, let's apply Q equals CV equation. Then C is 2 microfarad. That into 3, we get 6 microcoulombs. The charge in the 2 microfarad capacitor. So we have all the values now. I1 we have found as 1 milliampere, I2 0.5 milliampere, and finally the charge of the capacitor 6 microcoulomb.